In this video, I'm going to go through an example of an optimization problem. So in this example, we have a rectangular field, which is to be enclosed using 300 meters of fencing along 3 of its sides, and the 4th side is adjacent to a river and doesn't need any fencing. We want to determine the dimensions and area of the field, which have a maximum area. So the first step in most optimization problems is actually to draw a picture of the situation. So that's what I've done here. We've got 3 sides which will be covered by fencing, and then here's our river. The next thing you want to figure out when you're doing an optimization problem is what you're trying to optimize. So in this question it says we want to determine the dimensions and area of the field with a maximum or maximum area. So we need dimensions, so I'm going to use some variables for the dimensions of this field. So we'll call them x and y. And then you want to come up with an equation which represents that thing that you are trying to maximize, which in this case is the area. So the area of a rectangle, it's a pretty simple formula. We know that area equals x times y. Now we want to maximize this function. The problem with the function the way it is there's 2 variables, x and y. We have area equals area as a function of x and y. Using calculus, normally the way we would find the maximum value is we would take the derivative of the function, but we can't do that when the function depends on 2 things, x and y. So what we have to do is use this other information, the fact that we have 300 meters of fencing. So we have 300 meters of fencing. We know that's going to be used for these 3 sides, 2 x's and 1 y. So 300 is going to be equal to 2x plus y. Now if you look at this equation and you solve for one of the variables, in this case I'm going to solve for y. We could also solve for x, but slightly easier to solve for y, so we'll do that. And then we make a substitution into our area equation. So area equals x times, and now it's going to be times 300 minus 2x, replacing the y with 300 minus 2x. So now we have a function for area in terms of just x. So we could take the derivative of this function. I'll expand just to make the derivative a little bit easier. So multiplying the x by this bracket. Now I can find the derivative using the product or the power rule. So dA by dx is going to equal 300 minus 4x. Now to find the maximum value, we know that what we're looking for is the critical numbers of this function. So to find the critical numbers, we'll set the derivative equal to 0. So we get 4x equals 300, and solving for x, 300 over 4, x is equal to 75. So x equals 75 is a critical number. Now, we don't know that that necessarily yields a maximum. We know from previous unit or lessons that a critical number could be a maximum, could be a minimum, or it could be neither. So now the question is, how do we know this is a max? And there's a few ways you can use to prove that this is a maximum. One way, and the way that I almost always use, is the first derivative test. So the first derivative test, if you remember, you set up a table, and then along the top you're going to take the real number line and divide it in intervals at your critical numbers. Now in this case we're not going to use the whole real number line because we have restrictions on our x variable. Because x is a physical quantity, we know x must be bigger than 0. So I'm going to use 0 to my critical number, which is 75. But there's also an upper bound on x. Um, and that is because we're limited by how much fencing we can use. Getting the upper bound is sometimes a little bit tricky, or the other bound, because it's not explicitly given in the equation. So if we look at the equation, we know that x has to be bigger than 0 because it's a physical quantity, but y also has to be bigger than 0, which, it's nice to know, but it doesn't tell me anything specifically about x. But remember that y is equal to 300 minus 2x. And if I make this substitution in this inequality here, so since y is bigger than 0, that means 300 minus 2x is bigger than 0. And solving that linear inequality, we know that when you divide, you'll have to divide by -2, so you reverse the inequality. So we get x is less than 150. So we know x is less than 150 and x is bigger than 0. So if you want your restrictions on x, you know it's between 0 and 150. So in our first derivative test, sorry, that was dA by dx, we just need to figure out if the first derivative up here is positive or negative in these intervals. So just take a value between 0 and 75, substitute it into here. For example, if you took 1, 300 minus 4 times 1 would be a positive number. If you took a number in this interval, say 100, subbed it into here, you'd have 300 minus 4 times 100, which would be a negative number. So a positive first derivative means the function is increasing, and a negative first derivative means the function is decreasing. So at 75, the function changes from increasing to decreasing. Therefore, there is a maximum at x equals 75. Okay. So that's shown, that answers that question. How do we know it's a maximum? Now you just have to make sure you've answered the question. Going back to the original question, the question was, what are the dimensions? So the dimensions, we found one of the dimensions, x must be equal to 75. We're also going to need to figure out y, but remember, y is equal to 300 minus 2x. So y equals 300 minus 300 minus 2x, substituting 75 in for x, we'll get 300 minus 150. So y is equal to 300. And the question also asked, what is the area, which is the maximum. So we know that the dimensions of x equals 75 and y equals 300 give us a maximum area, but we have to actually figure out what that area is. So we'll go back and get the area equation. So remember, this is the area equation. So area equals 300x what's it? 300x minus 2x squared. And substitute 75 in. So 300 times 75 minus 2 times 75 squared, and work out what that is. And you get 11,250. Okay, so that's the maximum area. Now let's just go back and get the units. So the units here, there's 300 meters of fencing. So that means that the lengths were in meters and the area would be in meters squared. Okay, so the maximum area, therefore, the maximum area of the field is 11,250 meters squared with dimensions be 75 meters. Oh, I realized that's wrong. That should be 150 meters by 150 meters.